First, a word from our sponsor. These problems are hard. That's why I pick them for this review. Please don't get discouraged. Focus on what you can learn by doing them. I'm trying to squeeze in as much review as possible while doing these. So hang in there. Focus on what you can learn. In this problem, we're told that we're making a buffer. We start with 1 mole of a weak acid, acetic acid. It's a weak acid, and we're going to add half a mole of a strong base. So our chemical equation, what happens? We have a weak acid and a strong base. It's going to react completely to generate our conjugate of our weak acid and liquid water. We can construct a BCA table to help keep track of things. This is where we are before the reaction occurs. All of our base here is going to be consumed. It's essentially our limiting reagent. And we're going to lose that same amount of our weak acid. And we gain that amount of our conjugate base. So we can ask the question, what's in the beaker? Well, what's in the beaker is we have 0.5 moles of HA and we have 0.5 moles of its conjugate base. What we have is a balanced buffer. And when we have a balanced buffer, pH is equal to pKa. And this is also true halfway to equivalence in a titration of a weak acid plus a strong base. Halfway to equivalence, half of that initial amount of the acid has been converted to its conjugate base. So you have equal moles of HA, A-, that's a balanced buffer. And that's why, and the answer to the question is that the pH is going to be equal to the pKa for that acetic acid.